Hi friends, in this video we are going to see cascade form realization of discrete time system. This is the block diagram realization. Before we continue this video, please go through. Already I have uploaded two videos related to block diagram representation. One is direct form 1 and direct form 2. So how we can realize a given difference equation or given system function using direct form 1 and direct form 2. So I have posted two videos. Particularly you refer direct form 2 video, because without that video or without the knowledge of direct form realization, we cannot continue. We cannot implement a system using cascade form, because we are going to use the direct form realization in the cascade form. So the knowledge of direct form 2 realization is really important to understand cascade form. Okay, now we will continue this video. In the cascade form realization, we are going to realize a given system function as a product of several functions, or several functions, not two or more than two, it may be. Okay, those system functions can be, each system function can be realized using direct form 2 and they will be cascaded. So in the cascade realization, a given system function x of z will be expressed as product of different system functions, and they will be separately realized using direct form 2 and they will be cascaded. For example, you consider the function, this is the given system function, this is x of z. So we are going to represent given system function as a product of two system functions. This is system function 1 and this is system function 2. Okay, so these two functions, system functions, are realized using direct form 2. This is direct form 2 realization of h1 of z. This is direct form 2 realization of h2 of z. These two are cascaded here. These two, h1 of z and h2 of z, cascaded. The cascaded block diagram will be h of z. Okay, so understand this concept, we will see an example. In the example, we have to obtain a cascade form realization for the system which is described using difference equation. Okay, y of n minus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to x of n plus 3 x of n minus 1 plus 2 x of n minus 2. To find out the h of z, we have to take z transform for the given difference equation. If you take the z transform for y of n, you will get y of z. For y of n minus alpha, the Laplace transform will be, z transform will be, z minus alpha, here it is y of z. Okay, so here instead of alpha you have 1, so it is z power minus 1 y of z. Here instead of alpha you have 2, so it is z power minus 2 y of z. So because it is the time shifting property of z transform, using that property we are going to find out the z transform for the given difference equation. So here it is x of n, that is, if you take the z transform, that will be x of z, then 3 x of n minus 1, so z power minus 1 x of z, 2 x of n minus 2, so it is z power minus 2 x of z. To find out the h of z, what is h of z? H of z is the system function that is equal to y of z divided by x of z. So to find out this system function, we have to separate the y of z common. So that will give you 1 minus 1 by 4 z inverse minus 1 by 2 z power minus 2. Here you have to take the x of z common. That will give you 1 plus 3 z power minus 1 plus 2 z power minus 2. Now you take the x of z this left hand side. So now this is equal to h of z. So y of z divided by x of z, that is h of z, that is equal to, this term will come in the denominator, 1 plus 3 z power minus 1 plus 2 z power minus 2 divided by 1 minus 1 by 4 z power minus 1 minus 1 by 8 z power minus 2. Right? Now how this step came from this step? There are intermediate, there are some steps. I will write down that here. This is equal to z power minus 2 z squared plus 3z plus 2. If we take the z power minus 2 common in the denominator, this will become z squared minus 1 by 4z minus 1 by z. Okay. If you multiply this inside, you will get this. Okay. So z power minus 2 and z power minus 2 will cancel each other. If you factorize this numerator polynomial, denominator polynomial, you will get, if you factorize this can be written as z plus 1 z plus 2. Similarly, it will be z minus 1 by 2 z plus 1 by 4. How I factorized it? If you multiply these two terms, in what way you have to find out this? If you add the factors, you have to get this. That is, a plus b should be this coefficient and this should be a into b. So if you multiply these two, 1 into 2, you will get this. If you add 1 plus 2, you will get this. So you have to find the number which satisfies this condition. You have to find the number which two factors which satisfy this combination. That is 1 into 2, that will give you 2. That is ab, that will give you 2. A plus b, that is 3. Similarly for this also, if you add this minus 1 by 2 and plus 1 by 4, you will get minus 1 by 2. So, sorry, minus 1 by 4. So, this is a plus b. Similarly, if you multiply these two, this is a and this is b. So, ab, that is 1 by 8. This is ab, minus 1 by 8. Minus 1 by 2 and plus 1 by 4, if you multiply, you will get minus 1 by 8. So, this is the way you have to factorize a given number. If after this step, we have to take the z common in both numerator and denominator part. If you take the z common, that will become 1 plus z inverse. Then here also you take the z common. So z 1 plus is 2 z inverse. Similarly, the denominator part also, if you take the z common, z 1 minus 1 by 2 z inverse. Then here also you take the z common, 1 plus 1 by 4 z inverse. So z will cancel each other. So now you see you got this expression. Now this is your h1 of z and this is your h2 of z. Now you have to implement these two system functions separately using direct form 2. Here direct form 2 is how you will implement. Here h1 of z can be represented y1 of z divided by x1 of z. The same can be represented using y1 of z. A intermediate variable I am going to use w1 of z plus int w1 of z. w1 of z divided by x1 of z. These two terms will cancel, means you will get the original form. So this is a separate function and this is a separate function. So this expression can be represented using y1 of z divided by w1 of z, that is equal to 1 plus z power minus 1. This is w1 of z divided by x1 of z, that is 1 divided by 1 minus 1 by 2 z inverse. Okay, so here if we cross multiply this y1 of z is equal to w1 of z plus z power minus 1 w1 of z. If you draw the block diagram for this function, you will get output is y1 of z, then input is w1 of z. So this you will have a adder here, because y1 of z is sum of this and this. So y1 of this w1 of this will be directly added with a multiplier. Okay, here w1 of z into a delay element. So here you are going to put a delay element here, z power minus 1, then this will be added. After the delay, w1 of z is added with y1 of z. Okay, so y1 of z is equal to w1 of z plus z power minus 1 w1 of z. Okay, this part I implemented. Similarly for this, if you cross multiply this, you will get w1 of z minus 1 by 2 z power minus 1 w1 of z, that is equal to x1 of z. Now w1 of z is equal to x1 of z plus 1 by 2 z power minus 1 w1 of z. Now here the w1 of z is the output, x1 of z is the input. So w1 of z, then x1 of z is the input. Now w1 of z is equal to x1 of z plus then w1 of z. So we have to take the input from the w1 of z, then one delay element, then that will be multiplied with 1 by 2, then both x1 of z, then this term, both term will be added. Okay, x1 of z, then w1 of z into, both are added, that will be equal to w1 of z summation of x1 of z into x1 of z plus 1 by 2 z power minus 1 w1 of z. Okay, so here if you combine these two blocks, this block and this block, you will get the direct two form realization of this block diagram and this block diagram are going to be combined. So you got this direct form 2 realization of h1 of z. Similarly you have to do for h2 of z to find out the direct form 2 realization of h2 of z. Now these two realizations are going to be combined, cascaded, to find out the h of z. This is what we did here. Okay, so again I am telling, there are 4 types of realizations. Okay, direct form 1, direct form 2 and cascade form, and finally parallel form. For all this realization, direct form 2 realization is very important. If you understood direct form 2 realization, then you can easily realize other forms, cascade form and parallel form, because direct form 2 is the core realization of this cascade form and parallel form realization. Okay, Hope you understood this video content. In the next video, we will see parallel form realization of discrete time system. Thank you very much.